Explain me the OSM model one by one. Like I think I have given you the your part, the layers what you need to expect. Maybe you can explain it, and others can listen. And if you like, if suppose if you say something wrong, yeah, they will correct you. Let's start with Chidambar. Please go ahead. You there? Am I audible?
Yes.
Okay, seems he's busy. Bharat, can you go ahead with your? Maybe you can cover later.
Okay. Yeah. Morning, everybody. I'm going to do the presentation layer. In the presentation layer, uh, translates application to network format, and for the responsible for the protocol conversion, character conversions data in the presentation layer, uh, and it encrypts and decrypts the data, and the protocols are ASCII, GIF, MPEG for the presentation layer. And for the application layer used specially written to run over the network and allow access to network services to support applications. The protocols are HTTP. In the app, it shows HTTP, Telnet. That's it.
Okay. Sneha, can you go ahead?
Yes, sir. And my topic on transport layer.
Mhm.
Transport layer is an heart of OSI layer, and it performs end-to-end connectivity. And the main it is responsible to derive the data into a small pieces. It's in the form of segmentation, and it also controls error correction and flow controller, and it identifies the services, and that's it about transport. Next, network layer, and it also data flow. And when the data from the transport layer comes to the uh, networking layer, it can segment is converted into packets, and it is responsible for providing the best path for the data to reach its destination. And it is in logical addressing. It also performs the logical addressing, and it's we use here routers. Means it is a routers are used here. And next layer is data layer. And when the packet from the uh, networking layer to it comes, it convert into the frames, and here it does the logical operations are formed here, and moving frames from the nodes to node to node or computer to computer, and it requires MAC, and we use here switches, and there are it talks about protocols, and MAC means uh, medium access control, and it talks about the physical addressing of the frames to where to go. And next data link layer, and data link layer here we receive addresses from the flow control. It addresses about the flow control and address notifications and error control here, and determine which computer has to access to the networking medium to get to the given time. That's it, sir.
Yeah, it's fine. Thank you. Bharat, can you go ahead?
Yeah, yeah. Hi, team. My topic is about transport layer, and the transport layer is known as heart of the layer of a OSI model because it works as a host for software and hardware levels, and it provides services to application layer and takes services from the network layers. And data in the transport layer is known as segments, and it is responsible for delivering a message from end to end. And we use a protocols which known as TCP and UDP, and TCP stands for Transmission Control Protocol, and UDP as User Datagram Protocol. Whereas if we use a TCP, which is responsible from end to end, I mean delivering the message. Whereas if we use a UDP, we don't have any confirmation regarding a message is delivered or not. And the transport layer is most important layer in all the OSN model because it is a host where it connects hardware and software layers. And the next layer is session layer. This is one of the software layer which is operates in the application layer. It manages and synchronize the conversation between two applications and the termination. And it is responsible for establishment of connection, and it maintains the session with proper authentication and the security and its security. And the presentation layer, it is also called as a translation layer because it translates from one code to another code, and it can also do the encryption and decryption. And another thing is the main thing, it can do the data compression from one size to another. That's it.
Yeah, that's great.
And the protocols we use in the presentation layer is ASCII and MPEG, GIF.
Or HTTPS, HTTP, FTP. These are all protocols. Yeah. Like those are all application actually.
Okay.
That's good. Thanks everyone. Chidambar, you are the only one left. So can you start over? Okay, it's fine, no problem. Thanks, guys. At least you came up and you talked about something. I'm very happy. So let's continue the same each and every day. Like, yeah, whatever you know, just tell me. Whether it is right or wrong, it doesn't matter. But first, you need to talk. Then only, yeah, you can express yourself in the interviews also. That's what I want. Um, okay. So we have seen OSI models. That's fine. And let's go to Internet Protocol. Okay. So I'm telling you, Internet Protocol is the most important one because without internet we like without IP address there is nothing in the network. Okay, so just understand that first. So we have to know each and everything related to the IP addresses. Okay, so I'll explain, maybe I'll go speed or maybe something I miss or maybe you will not understand something, just ask me. There is no problem, I can explain you multiple times, huh? Okay, Internet Protocol. So we are talking about IP, right? So IP means Internet Protocol. Okay. So the Internet Protocol basically has two versions. So before what it contains actually, what is IP? So what it contains means, so we discussed it, right? Like it will like suppose you are forwarding some data and so you want to send some data from your machine to my machine, okay? So whenever it is doing that, so what it will do is it will have a IP table. I told you, right? Routers will contain a dedicated routing table so that it can pass the information. Okay. So same way. So whenever you want to send some data, so first, if I want to initiate connection to you, my IP will be the source IP, right? Source IP. And next, I want to deliver it to you. So your IP is your destination IP. And so from which port I want to, like source port we will never define, but yeah, basically it will carry that information also. But the destination port is mandatory. Okay, and so that is the packet. But normally in IP packet you will have source address, destination address, and so what is your version? Like okay, let me grab it here. That Okay, so this is how a IP packet looks like. So whenever like if you see any data or any IP address, so basically that is a logical representation, like the user understandable representation. But when it comes to us, mostly when it comes to its original state, it will have all of this info on that packet whenever it is carrying some information. Okay, so basically in IP, in internet protocol. So internet protocol means IP protocol. We have two versions. Okay, IP. So it has two versions. One is IPv4 and another one is IPv6. Okay, IPv4 and IPv6. So IPv4 is in the normal decimal format. IPv6 is in the hexadecimal format. Okay. If you want to see, just go to this and just control C. Just type ipconfig. Okay. So here, if you see, I'm getting IPv6 address, but in the same way, so this is the IPv6 address, and this is our IPv4 address. Okay, but in most of the cases we will use the IPv4 only. And not only most of the cases we are using IPv4 only, but few vendors, mostly if you see Geo is updated to IPv6, they are using it. Okay, so it contains like this. So total, so these things will be called as a fields. So how many fields are there? 1 2 3 4 5 6 7 8. So 8 fields, and each field has 4 bits. Okay, so like that. So this is how IPv6 looks like, and this is IPv4. So IPv4 has total 4 octets. Okay, so this will be called as octet. 192 is one octet, 168 is one octet, 29 is one octet, and 41 is one octet. Okay, I'll tell you why we will call it as octet. So what is meant by octet means 8. So 2 power 8. So what is the value? 32 bits, right? So in a IP, we will have total 32 bits. So how you will represent those 32 bits means, so I told you, we will represent it in zeros and ones only. Okay. So it will be like this 0 1 0 1 0 1 0 1 0 1 0 1 0. So total 32 bits it will store. Whatever the data it is, but it will be defined in this way only. Okay, I'm just taking it as an example, like just telling you as an example. So it looks like this, but in real scenario, how we will see that 192.168.1.1. Okay. So here the first is version. So it has 4 bits. Okay. And next, IHL. IHL means IHL means one minute. Yeah. Okay. It's header length. So first version tells us which version of IP you are using, and next one is the header length. So it has a 4 bits of information, and so it will tell you like so I we discussed it right yesterday. It will have a header and footer. So it will add a 4 bits of header like before your IP address. Well, and it will make sure your 32-bit of IP information is passed to the destination. Okay. So the minimum 4 bits means 2 power 4, 16 bits, 16 bytes. The maximum value is 4 bits, so it's 15. So with the 32-bit increment, that would be 32 bits into 4 bits. Okay. So whatever the binary value is, so that binary value you will calculate with the 2 power values. Okay. So right now version is 4 bits. That means 2 power 4. What is this 16 bits? But basically we will count from 0. So 0 to 15. And same way header length also 4 bits, but it's a 2 power 4. So that means 16 bytes. So that's how we will look into this. And this header length will contain the head of packet, like which will guarantee your IP address um, transmission to the destination. Okay. And the next one is service type. Okay. So it is a quality of service thing, like how we can trust our data to be delivered to the destination. So it's a QoS thing. We will do it in the switching. Then you will understand it. And so it is a 8 bits. Okay. And we can use it to mark packet, which we can use the QoS quality of service, where you can tag it is like if I say, like in our network we will use QoS things actually, but it is very rare. But so what it is mean general, I'll tell you, like whenever you want to transfer some data, so you want to give an assurance like your data will be transferred to the destination. And one more thing, you will deliver the original data itself, like there is no changes in our data. So that is for we are responsible, right? So that is the service, that is called a service type. Okay. So So this is the total length. It represents what is the header component we have. So if you see version is 4 bits and header length is 4 bits and service type is 4 bits, sorry, 8 bits. So if you compare total, it is 16 bits, and it can go up to maximum 65,535 bytes also. Okay. And next, identification. Identification is so we talked about the this one, right? Fragmentation, like in data link layer, the data is divided into the frames, right? So when we do that, so the division will be called as a fragmentation. Okay. So whenever you transfer the, like whenever the fragment is transferred, it will have the a identification number before that. Okay. So which is a 16 bits number to identify the fragment. Like for example, if I say I will divide this packet into, so for example, this is a fragment and this is a fragment and this is a fragment. Okay, so you will start delivering the data. So maybe this one can go first and this one go first and this one next and this one next and last it went. So but it has to be in the order, right? Like 1 2 3 4 5, but the data is delivered in 2 3 4 5 1 in that way. So the destination should need to reorder them, right? Like it needs to be on the same what do you say, like whatever the way it is originally, it has to be same in the destination side also. Okay, that's why we will use this identification numbers. Okay, and next one is flags. So these will be called as the IP flags, and so there are total 3 bits we will use in the IP flags. So the first bit is always 0. Okay, and the second bit is called as a DF. DF means don't fragment. So that means the packet should not be fragmented. Like there is no need to like divide the packet into multiple types. Okay, and the third is called MF, like more fragments. Suppose there is a large amount of data and you are not able to transfer it to the destination because there are certain things we need to consider. We cannot transfer, like you are a high-end laptop and I have very low-end laptop. So you are transferring with the 10 example, you are transferring with the 10 gig speed, but I have only 1 Gbps internet connection. So how much I can receive? Only 1 Gbps I can receive, right? In the same way, there are certain things we cannot transfer the data in a larger amount, even though you have the higher thing. So same way, it will has these three flags. Whenever it sets a flag like a 0, yeah, it will do the fragmentation definitely. And if you set the bit to we will not set it. Okay, it's a by default thing. Okay, and the DF, yeah, it will do the, it will not, it will never do the fragmentation. And the third one is MF, more fragmentation. So like it will divide into the more frames. Okay, and the next one is fragment offset. So fragment offset means specifies the yeah. So we have discussed, right, like the order, like where the original fragment packet is. Suppose you received data in 1 3 4 5 2 format. Okay, and so in order to rearrange them, so we have this offset like a 0 or 1, 0 or 1. So whatever it is, we will represent in the zeros and ones only, right? So by using this fragment offset, we will rearrange the packet in original place. Like suppose 2 should be here, right? And 3 should be here, and 4 should be here, 5 should be there at the last. So that's how. In order to arrange the packet, it will use the fragment offset. Like for suppose everything here, suppose you have written some assignments, example, it went on multiple pages. So how you will define? You will give the page numbers, right? So that only you will rearrange them in a same order. So same way, the package means it has large data and there are number of packets. So how computer can understand? So by setting these fields, like by enabling them, you can understand it, and by disabling them, it will transfer the data randomly. Okay, so that's why. And time to live. So if you see, if you reach out to, suppose if I try to ping google.com, so you are seeing a time, right? Yeah. So how much time I'm taking to reach the Google here? 31 milliseconds, 36 milliseconds, 46 milliseconds. So that's based on your connectivity. So whenever any packet enter into any network, it has a TTL value like time to live. So how much time the packet can be alive? Okay. So this TTL value will increase. Suppose you are here and you are going to the internet. Okay, you are going to the internet, and in between you have other 30 routers. Okay, like, so there are many routers in between you and Google. So you are here, so this is your place. So what happened? So whether it once it started here, maybe the TTL value is for example, if I say 30 milliseconds. Okay, so you reached here. Okay, then it will increase to 1. Okay. Whenever you pass each hop in your network or each router in your network, the TTL value increases to 1. So now you will become 31. Then it will come here, you will become 32 and then 33. So because, so this is called a latency. If you see, if I want to reach here, I am going these many hops, right? I'm going through these many hops. So this is the time for to reach the first one. I'm taking 30 seconds, and so to reach the next one, mostly I'll take 31, 32 seconds, right? The time will increase. It's depend on the situation. So that's why. Let me show you one thing here. Trace route. Hold on. Sorry. Trace route. Google.com. So this is the first hop, like our gateway. I took 2 milliseconds to reach there. Okay. Then the next hop I took 7 milliseconds. Then the next hop 24 milliseconds. Then the next hop 23 milliseconds. Then after that 22 milliseconds. So total it should reach or go through maximum 30 hops. Like if any network also, it will prefer only 30 hops. Okay. So that's how the TTL value will be calculated. So the time to reach the next hop. Okay, so basically by default you will have 1 or 2 milliseconds time. So once you reach here, okay, that's fine, you will reach it in the 2 milliseconds. But the next one, so it will not calculate from here to here, it will calculate from here to here how much time it is taking. Okay, so sometimes when you are working, users will notify like they are facing some latency. Okay, that time what we will do, we will take the trace route and we will see, oh, okay, where it is taking longer time. So if you see here, so for example, I'll say in the third hop, from our machine to reach the third hop, we are taking only 7 milliseconds, but from third hop to fourth hop, so hop means router, okay? So third hop to fourth hop, we are taking 24 milliseconds. So there is a long time, right? So 7 to 24 means already we are seeing 15 milliseconds increase. So there is some latency here. But after that, if you see, it is going down. Like the connectivity is fine after fourth hop, but the connectivity between third and fourth is not accurate. So yeah, we will verify on these two. like maybe there is some cable issue, or maybe the path is going in a different way, maybe. So the latency can happen in many ways. Like suppose you are here and you want to go to internet. If you go directly, like only with your Wi-Fi router, so that's fine, right? There are no many hops, so you will reach it directly. The speed is very high. But if you want to go through all these routers, so each router will take its own time to process your packet. So the latency very high. So that's the time to leave. So the TTL value we will calculate based on the how many hops we are going through, how many hops we are passing through while reaching the destination. Okay, so that is the TTL value. And the next one is the protocol. You know what protocols we are using? TCP, transport layer protocols. Either one is a TCP or a UDP. Okay, each one has 8 bits. Okay, so 8 bits means, so to port it, so total. So whether it is a TCP or a UDP, so it has some data. Like in a TCP, we will have source IP, destination IP, source port, destination port details. Okay, whenever it is transferring the data. And the next one is so the checksum, header checksum. So we told, right, this layer 3 devices, each layer performs some like error check or something like that. So like error detection and error check. So for that it will use a header checksum. So because by comparing this header checksum value, like it will confirm like, okay, whatever the packet transferred from the source, that is reached the destination by using this header checksum. Okay, I will show you all these fields in the packet tracer. Okay, and the source IP address. So your system IP and where you want to transfer the data. So that is called destination IP. And the last one is data. So the original data you are transferring. So right now I'm talking. So that is my original data, and mine is source IP and yours is destination IP. So in order to my data is delivered, in order to deliver my data as it is, like my voice as it is, so it will consider these many fields. So first it will verify what version of IP what version of IP I am using, and next it will add a header length so that it can identify the packet in the destination, and then it will use the type of service. So like service type, it's based on the your configuration. Okay, the service type. So quality of service thing, whether you want to whether that data is delivering exactly or not. So in order to verify on our own, we will use this QoS service. Okay, and then identification number, like to identify each and every packet in the destination, like the fragmented packet. So this identification number. So I'm sending packets here, like, and I want to identify. So it will add a 0 here and it will add a 1 here. So it will identify. So okay, 0 the before the before the packet it will add 0, and after the packet it will add header footer. So 0 1. So it will identify whenever it receives in the destination. What it will do is like, so this is your total packet, right? And you added a header and footer. So here this is your header and this is your footer, and in between your data is there. So in the destination, what it will do, it will remove these two and calculate only this part, because this is the original data. Okay, so that's how. And next the flags, like whether the packet needs to be fragmented or not. And if fragmented needs, so it uses more fragment, right? And a fragment offset, offset is like so it needs to specify the position of original packet. Like we are transferring this, but the so you are adding header and footer here, identification to identify the packet. But so where this needs to be placed, like same way you will transfer multiple frames, right? Like multiple packets, right? So it will has also header and footer. So where I will add the this packet, like in order to represent. hi, how are you? So it should be delivered like hi, how are you only. It shouldn't be like you, how, hi. So for that fragmentation, yeah, we will use this offset bit. So it will arrange the data in a original manner. Okay. So the TTL, like how many hops we have in between the source and destination. So it will take that much time, and the TTL value can be increased to 1 after it is reaching each and every router. So if it reaches here, the value will become 30, and then it will 31, and then it will become 32, because it is taking time to reach, right? So it will get increased to +1 always. Protocol. So whether it is a TCP or UDP protocol, so transmission control protocol or a user datagram protocol. So the basic thing. Whenever we will try to communicate with other guys, so it goes based on the ports only, like the protocol, whether it is a TCP or UDP. Okay, so so it will have that information, and the port number can be defined in the 8 bits. Okay, and the last one is header checksum, like so it will see by considering that header checksum, it will verify the packet and it see like if there are any errors in the packet or not. Okay, and apart from that, you will have your source address and destination address and data in your IPv4 header. Okay, this is they will ask you this in interview. Okay, let me show you this IPv4 header in. Okay, I'll show you that later. So is it okay, or any doubts? Just let me know. We'll discuss. Hey guys, please respond. If it is okay, I will go forward. If not, yeah, we'll discuss it again. Am I audible?
Yeah.
సో అందరికి అర్థమైందా? Hey guys, please respond కొంచెం ఫ్రీ ఉండండి, నో
Yeah.
ప్రాబ్లం, వాట్ ఎవర్ ఇట్ ఈస్.
Okay.
Whether you understand it or not, just leave it. Free ఉండండి first, like then don't feel like it is a class, and yeah, you can call me. We no need to call me as a star. So just feel free. Then we can enjoy it. Like feel it is like some journey. Like don't feel like every day you need to wake up at 7 and you need to join and you need to wait for 2 hours to complete. Just don't feel like that, because you are planning your career in this way, right? Like in this network field, right? So whenever, wherever you go or whatever the technology you choose, first you need to talk. Like you need to express yourself, right? So like whether you are understanding it or not. Suppose you went to a company and you joined a meeting, like a project meeting, and so I'm the guy. I explained you like this is my requirement. I want so need to be done. So you listen and you don't understand anything. Then what you will do? You should respond, right? That will start from here only. So you just feel same way, whether it is work or whether it is learning, whatever it is. First, we need to ask. Like if you don't understand what you will do, you won't do anything. Even though if you do also, they won't accept it. The solution. I'm just going to show you this this IP header in real time. Okay, so right now I'm using the Wi-Fi connection, right? So I'm just capturing the traffic on my Wi-Fi. Okay, that's it. It is more than enough. Okay, you guys are able to see the Wireshark, right?
Yes, Sandesh.
Yeah. So here, if you see Internet Protocol version 4, okay. So here you are seeing, right? So the first part is your version. Let me paste it in the paint. So just see it here. So whatever we discussed. So the first is version. Which version it is? Okay, so version 4. So what is the number of 4? So it is 2 power 0. Okay, so the value will be calculated in this way. Okay, you have total by default 32 bits in IP. Okay, so total 32 bits. So we will call them as a 4 octets. Okay, so this is your, for example, this is yours IP packet 1, 2, 3, 4. Okay, so 1, 2, 3, and 4. So here, so total IP is 32 bits. Okay. So here in these 32 bits, so we will divide these 32 bits into 4 octets. Just listen guys carefully. So this is divided into 4 octets. So 4 octets, and each octet has how many bits? 8 bits. Okay. So total 4 8 are 32 bits of information we will have. Okay, 32 bits. So this is our normal. So first you will divide it into 4 octets, 1 2 3 4. So this is our, each octet is equal to 8 bits. Okay, so the 8 bits means 0 1 0 1, that way I'm saying. Okay, so 0 1 0 1 or all zeros. Okay, whatever it is, but total 8 bits. Okay, and So total, by combining all of this, you have 32 bits, right? So your IP address is total 32 bits of information, and it is divided into 4 octets. So each octet has 8 bits of information, like each octet contains 8 bits. Okay. So here we will call this as a network. So basically, so the first 3 will be called as a network octets, and the rest 2 called as a host. I'll tell you the difference. So this is the network part, and this is the okay. So by using the network only, you will understand like which IP it is using and which class it is using. So all this we will understand it by using this IP only. Okay. So next, so here you understand it, right? So it has the total 32 bits. So if you see, so the version is 4. That means IPv4. We are in the decimal format. I will tell you what is our IP. 192.168.29.41. So this is the decimal format only, right? So this is the decimal format only, and the destination also in the decimal format only. So that's why it is saying version 4, and it is represented it in, for us it is represented in 4, but for a computer it is represented in 0100. So 0100. You guys know how to calculate the binary values? So So just let me tell you, 0010, right? So it is 0, 1, 2, 3. So all the binary values can be calculated by using 2 power value. Okay. So that means 2 power 0, 2 power 1, 2 power 2, and 2 power 3. So in a binary, if you want to get 4 number, what you need to take? So 0010 only, right? If I want to go with the 8, what will be our binary number? 1000, right? Hope you are getting it. You know, right? Just respond, please, guys. Uh, you know how to calculate the binary values? Sneha, Bharat, Chidambar, Bharat.
Actually, no.
Okay.
ఒకసారి
So you
ఎక్స్ప్లెయిన్ చేయండి సార్.
sorry.
ఒకసారి బైనరీ ఒకసారి చెప్పండి సార్.
Okay. So example, you want to calculate the binary value of, just give me a random number. Let's go for 9. Okay, for example. So how we will calculate is, so basically it has 4 octets, right? So 240. So by default it is like this. So simple, guys. So you want to calculate just whatever the value it is, just see it in this way. 2 power 0 because it is first position, 2 power 1 second position, 2 power 2 third position, 2 power 3 fourth position. Okay, so these are our values. So suppose you want to calculate binary value for number 1. Okay, so what is the value of 2 power 0? 1, right? And you got your 1, like 2 power 0 is 1. I'm just talking about the our values, not in the binary. 2 power 0 is 1. So if you got your 2 power 0 value as 1, so you can, So here the 1 means active, 0 means offline. Just think it in that way. So 0, 0, 0. So 0, 0, 0, 1 represents number 1, right?
1.
So in the same way, if you want to represent, for example, take 5. Okay, you want to represent 5. So for number 5, what will be our binary code? So 2 power 0,
1, 1.
0, 2 power 1, 1, 2 power 2, sorry, 101, sorry, 2 power 2, 2 gal. So yeah, so 101, 01, 01. So that is our binary value for 2 power 5. In the same way, if you want to write for 9, what will be our value? So 2 power 0 is 1. So we will use this. 2 power 1 is 2. We don't need that. 2 power 2, 4.
0,
We don't
1.
need that. So 2 power 3, 8. So 1001. We can use this, right? If you add 8 plus 1, it is going to be 9.
No.
So you got it? So same
Yeah.
way. So here it is calculated for binary value for 4, 0, 1, 00. And this is your version. So guys, whatever the IP we discussed, IP packet we discussed in the theoretical, I'm just captured in my laptop and I'm just pasting that screenshot here. If you see, so this is my source address and this is my destination address, and inside that we have the all this information, whatever we discussed now. Okay, so we have the version, we have the header length. Okay, everything will be represented in a binary language for computer, and for your understanding, it will be represented in user language. Okay, you have everything here. What is the total length and what is the identification number? What is the flag? Okay, so here it is setting resort bit or don't fragment or more fragment bits, and TTL value 128. What is the protocol we are using here? Okay, so what is the protocol we are using here? We are using UDP. Okay, header checksum value, and what is your source address and destination address, and the port details. I told you, right, whenever we have port, it will contain source port and destination port details. And after that you have your data also. If you see end. Okay, so that is how your real time also looks like. Both are similar, like in your real time and here. So your data also, see, it will be converted into this format only, like it will convert into the ASCII format, like the computer understandable language. Okay, so it will encrypt everything and it will transfer. Okay, so how much length is your message, and what is the length of your message? So everything will be calculated and it can forward it to the destination. So that is our IP protocol. Okay, so here we have our IP protocol, and now you got some at least little bit idea, right? What is the binary and how IP protocol looks like. So here you are saying 192.168.29.41. So what is that actually? What is 22.110.166.21? What is that? So now we will look into them. So these IP addresses, so wherever you go, you will see total divided into 3 classes. Okay, so these IP addresses will be divided into 3 classes. One is class A, class B, and class C. Okay, so whatever the IP addresses you will see, mostly those IPs will be part from either class A, class B, or class C. Okay, so here, uh, so what is class A and class B and class C? How you will differentiate them? So how many octets we have in a IP? We have 4 octets, right?
Yes. 32 bits.
So I'm just writing one for class A and one for class B and one for class C. This is your network part. So this is your network, and these are the host bits. Okay. Host. So this is for class A, and the next one is class B. This is network. These two are the host bits. That is for class C. Oh, sorry, class B. Network. Host. Okay. So here the host means, and what is the network means, and what is the host means. So the host means your machine. Okay, how many machines you will connect. So here you are seeing the IP address, right? 192, 192.168.29.41 as my system IP. Okay, 29.41, right? So in this 41 represents my mission. Okay, so 41 represents my mission. So same way, whatever, wherever, whatever the network. So the host part will represent the user details. 41 represents my IP, and maybe 42 is your IP, 43 is someone else IP, right? So we cannot like we cannot choose which IP you need to get. Okay, so we will get assigned with 41. So that is my IP, and it represents my mission. Okay, so here if you see each class, so class A, B, and class C. So if you see just example, so how many hosts we can connect in a class A? That is the question, your interview question. Okay, so how many bits we have in an octet? You guys need to respond. I won't tell this one. You just respond, or else I'll leave it here. So how many octets are there in front of you?
8 bits.
So in an octet we have 8 bits, right? And we
Yes.
have total
32
four,
bits.
yeah, 4 octets, so 32 bits. So here in class A, so I'm representing class A now. So how many
Okay.
network bits we have?
4 bit. 32
8
bits.
network bits. 8 network bits.
Okay.
One octet only, right?
Yes, sir. Okay.
Yeah. And how many host bits we have? Total
3.
24. Yeah, 3 octets and 24 bits. Okay. So what is the value of 2 power 24?
1024.
1024 is 2 power 9, I think. 2 power 8 or 9. Okay, so for example, just leave it. So we can connect up to 65,535 devices in Class A network. 535. We can connect up to 65,535 devices in a Class A network. Okay. So you have one network and 3 host bits. So that means it is giving you flexibility to connect with the more hosts. Okay. So just don't go deeper. I'm just telling you the difference between all the classes first before going to the numbers. So it is 65,535 hosts we can connect here. In the same way, calculate for class B and let me know how many hosts we can connect. So we have 2 network bits and we have 2 host bits.
Host
So
bits
what is the value of 2 power 5?
over 5.
Sorry, 2 power 8, 2 power 8.
$256.
Yeah. So here 2 power how much? Just come from here 2 power 0, 2 power 1, 2 power 8, 2 power 9, 10, 11, 2 power 16 value. What is it? 2 power 16 value. 2 power 16 value. 2 power 16. Sorry. And 2 power 24 value. Okay, just a mistake. So in the class A, we have 3 hosts, right? So that means total how many bits? 24 bits has a host, right? So that means 2 power 24. The value is 167777216. So these many hosts we can connect in the class A. I'm sorry, I mentioned 65. That is for class B actually. Because here we have 8 plus 8, how many total? 16 bits only, right? So
16.
what is the value of 2 power 16? Then it will become as a 65,535. Okay. In class C, just go to class C and see how many network bits we have and how many host bits we have. So what is the network bits value in class B? Whether it is 8 or 16 or 24 or 32.
16.
Class B, yeah, you're correct, 16. And what it is in the class C?
24
24. In class A?
is 8.
8. So that's how you will physically show which class it is. You got it? If you want to represent a class C address, you will represent it as a slash 24. If you want to represent a class B, you will represent it as a slash 16. And if you want to represent a class A, you will represent it as a slash 8. Okay, so here we have more than 16 million addresses in class C, A, and in class B we can connect up to 65,535 And this one in class C we can connect only 255 per network, because what is the value of 248? 256, right? So we will count from 0. So 0 to 255 only. So we can connect maximum only 255 hosts. Okay, that is for class. Two 55 host on which class? Is it in class B or class C or
Class
class
C.
A?
Class B.
That's
Yeah, class C. Okay. So here, so these classes is divided into based on a number. So okay. So how they calculated it? That also we need to know, right? Okay. Let me move this to. Okay, first I'm telling about class A. Okay, so how many bits we have? One network bit and three host bits, right? In class A.
Yes.
So here the host bits represents with 0 and the network bits represents with 1. Got it?
1.
So here, what is the value of class A then? It's 1000, right?
Yeah.
Oh, it's not like that. Yeah, network represents with 1 and host represents with 0. That is fine. But so here the class A is network and host. So class B is, so it has two networks, host and host.
And 2 hosts.
Oh, yeah. And class C is three networks, right? Network, and host. Okay, so here you have this value, and just calculate your network part here. Just that's it. So what is the binary flow we will follow? Like 0, 1, 2, right? Like 2 power 0, 2 power 0, and 2 power 1, and
2 power 2.
2 power 2. So 2 power 2 means, yeah, maybe 1, 1. So, so we will follow this way. So like the first bit in the binary always the 0, and the class B is so how they define the class B is like the first two bits always 1 0, and the first three bits always have to be 1 1 0. So based on that they have designed into three different classes. So the first bit is always 0, and the first two bits always to be 1 0, and the three bits should be 1 1 0. So here the class A is this one, and class B and class C, right? So what is the value of 1 0 in binary? In an octet,
3.
just consider it as a 8 bits. Okay, so 0 0 0 0 0 1 2 3 4 5 6 7. Your eighth bit is 1, and This one is 1 1 0 0 0 0 0. Okay, it's 2 power 0, 2 power 1, 2 power 2, 2 power 3, 4, 5, 6, 7. So what is the value of 2 power 7? 120,
256.
128, 2 power 7.
Yeah.
120.
Yeah.
Yeah.
128.
Yeah. So here, same way, calculate bottom one also, like for class C. 2 power 0, 2 power 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, maybe it is also 0. I'll add one more, total 8 bits, right? So 2 power 6 and 2 power 7. So what is the value of 2 power 7? Same 128. And what is the value of 2 power 6? Because here we have two ones, right? We need to add them. Okay. Plus
Okay.
2 power 6 means
64.
64.
64. So what is the total value?
282.
No. Just remember, in an octet, we have only 8 bits. Okay. So what is the maximum value? 2 power 8 is
Okay,
254,
256.
256. So we cannot go
Yes.
more 256. So if you don't know, also sometimes, yeah, 128 plus 64, you can calculate it like 190. So 2 plus 8. So 6 plus 180, 180 and 192, right? Is it correct? 192, right?
182.
192.
Yes.
Yeah.
Yes.
192.
Yeah. 192. Okay. So here, that's how they define the classes. So class C always starts from 192. Class B always starts from 128. Class A always starts from 0 to 127. Okay, these are the class ranges. You got it? How they calculated it. So, just wait. So the class A range is 0 to 127. Whatever you see the network in between 0 to 127, that is related to class A. And class B range is 128 to, what is the class C value? 192, right? So
Yes.
before that,
190.
191.
190.
That is class B value. And class C is 192 to, so what is our network? 192 to 250.
6.
So what is the value of 2 power 8? 256, right? So that means we can go up to 255, 0 to 255. So that is a class C value. So what? So they'll ask you what are the class A, B, and C ranges. So you can say and how they are calculated it. So always the first bit is always 0 and the second bit is always 10 and the third bit is always 110. So they took a single octet and they divided it into three parts and then they concluded it as a three classes. Okay, so the class A is 0 to 127 and class B is 128 to 191 and class C is 192 to 225. Let's hope you got it.
Yes.
Yes.
Okay. So just tell me if you got it, what is my IP, whether it is class A or class B or class C? So here you are seeing, right, 192.168.29.41.
Class C.
Okay.
Class
So if
Class
it is
C.
a class C, what are the network bits and what are the host bits here? How many network ports I have and how many host ports I have?
Network is 3 and host
3
is 1.
and host is 1.
Okay. So what is 20, 210 and 166.21? 20, 210, 166.21. Which class it
Class,
is?
class A.
So how many network bits and how many host bits are there?
1 network and 3 hosts.
Okay. So what is the network here? 20 or 210?
20 is network.
20.
Yeah. Okay. So here in this also we will not use all the IPs for our purpose. So there are certain ranges. If you see here the 127, you will never see it, but I will show you here. You guys observed yesterday also we have seen 127.0.0.1, 127.0.0.1. So this is called as a loopback network. Okay, we will never see it in real time, but your system will try to understand like whether it is working properly or not on this 127 network. Okay, so it is same for everyone and every laptop. So it dedicatedly internally it will work on 127. So if 127 is not using here, so we can say right, class A is 0 to 126 only, right? One 127 we will not use in a normal, if I say in the general purpose. Like we cannot assign that IP to our system. So these are the IPs, okay, but there are some reserved categories also, right? So there are some reserved categories. So 127 is reserved for loopback. Okay, this is for loopback. In the same way, in class C, we will never use until 255. We will use from 192 to 223 only. I'll tell you why. Because after that, you have these guys like defense is there and research and development is there, like ISO and all those. They have dedicated some dedicated space to them also. Okay, we will use till only 223. Okay,
Three.
so, so remaining will be called as a 224 and 227. So all them is called as a multi-cache addresses also. Like in routing itself, like in your routing and switching, it will use some protocols internally to communicate with one router to another router. So for that we need some multi-cache addresses. So that series will start from 224. So there are some defense dedicated IPs. So that those things will be used in there itself. And there are some for research and development, like for ISRO and these kind of things. So for all of them, there is a certain category, and we will never use them in our environments. Okay. So
Yeah.
we will use from 192 to 223 only in the class C network. Okay. So then next. So this is how your class A IP looks like. Suppose you are using one, that is the network, right? So what is your range? 0 to 126. So you want to write
120.
something in so 0.0.0 is a default network. Okay, we will never use that one also because I'll show you. So if you don't know anything or you don't have any idea where to go, it will go to default network. Okay, by default that is a internet forwarder. Like suppose ipconfig config, yeah. So here I have this gateway, right? 192.168.29.1. That is my router IP. So some in cases if I don't have any router, it will take it as a default route. Okay. So default route, or in some cases, if you don't know where is this host, you will receive it from internet. So that is also called as a default. So we will never use zero network also. So we will start from 1 to 126. So 1 is your network, and 0 represents your host, 0 represents your host. So suppose you are a system. So for example, I am taking Bharat. You are the as a number one. So number one always has a gateway. You have seen it, right? You will assign it to your router. So start using from 2. So Bharat is 2. And what is the next IP? 1.0.3.
3.
So like that, you have many users. So how many users I can go up to in this same network? Like
126.
1.0.0.255. Okay. Suppose this is filled up and I have many users. So what it will do? So this is filled up, right? This 255 part is filled up. Then what it will do is it will go back to next octet. Okay. So the
Sorry,
next
Vinod, sorry
octet,
to disturb.
yeah.
You said just like 223, we use up to only 223 lines.
That is networks I'm telling, but we are talking about the hosts in a class A network. So
Oh,
networks are different and hosts are different, right? What is the class A scenario? So it has 3 host bits and 1 network
one
bit, right?
network. Yeah.
Okay. So this is your network and this is your host bits. So this is your host bits. So you want to know like how many users can connect to a single network. So I'm saying so we have total 8 bits in a octet. So that means 2 power 8. Okay. So and I just forgot that I have to tell you a formula also here. So usable IPs, that is one concept. Like I told you, always we will use 1.0.0.1 as a gateway IP, right? Like that means you will assign it to your router. So this is how, like 29.1, that is my gateway. That means that is my router. Okay. And so one more is the broadcast IP 1.0.0.255. It is a broadcast IP. Okay. We don't use these two. So always, whenever you consider a network, you need to minus these two also. So here, for example, you are using this octet, and right now you have a requirement. Suppose someone came to you. Example, I'm just saying. Someone came to you and they asked you to give like a 20,000 or 30,000 IPs. Okay, so you are okay to give them. So how you will calculate whether you are giving that much or not? Suppose you are considering all of this. Okay, so how many bits we have total? 2 power 24. So 2 power 24 minus. So what we are going to remove here? One is your gateway and one is your broadcast IP minus 2. So whatever the value is, we will give it to them. So that's how we will calculate it. That is the formula basically we will follow. For example, I will tell you in class C because that is a small network, right? You will understand it easily. But okay, so 2 power 8 is our maximum, right? In a octet. So what is our value? 255. Okay, so here just think you assign till 254. Okay, and your network is filled up, and you have more users coming, and you want to assign them something like they are not listening to you, like they want more IPs. They are telling you. So what you will do at that time? So first, what you will do? So 0.254 is completed. Then what you will do is like 1.0.1.1. You will start from here because in each octet we have 255, right? So first it is zero network. So first it is zero network, and now we are going with one network. Like now your IP will is changed. It became 1.0.1, but earlier it is 1.0.0. Why we moved here? Because there are 255 hosts are filled in 0.255. So there is no option to move forward here. So then what is the next IP here? 1.0.1. 1.1. We will go here. And then we will use this till 1.0.1.255. So same way, you will go from here to 1.0.255. 255 you can use, right? Like I am ignoring in between the networks. So same way you can go to 1.0.2, 1.0.3, 1.0.4. So these are your host IPs, but these are your networks. 1.0.2, 3, 4, 5, like that. You can assign many IPs. Okay. So at last you will see like 1.255.255.255.
255.225.
So that means you will achieve your 17 million IPs. Okay. Hope you got it. So same way for class B. So what are the network and host bits in the class B? Just tell me quickly.
Network,
Two
host, and
networks.
host.
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 So how many usable IPs we will have in the class B? Network.
1.255.255.
So from where the class B will start? What is the range of class B starting range?
125.
20, 128.
128 to 191 is the
Sorry, 120.
class B. Okay. So what is the
Okay.
range of class A? 1 to 126.
7.
Yeah, 7. And what is the range of class C? 192 to
255.
255.
255. Okay, maybe we will not use few, but yeah, those are also part of class C. Okay, you can mention them, no issues. Okay, here, the one more thing we need to learn, and later, yeah, we can see few things. So here, okay, so this is a class B and class C. So it has a for example, if you want to represent your class A network, how you will represent it? Like how many bits we have in class A network bits?
8 bits.
So 8 bits. That
Class
means
A.
/8. Like you can represent in this way, right? 1.0.0.0/8. So by saying this, I'll understand it as a class A. In the same way, we have class B. So you will represent it in 172.16.0.0. So what is the network value in network bits value in class C?
24.
Class C 16. Sorry, class B 16. Sorry. So if you want to represent your class C, 192.168.1.0/24.
24.
So you are able to understand it, right? Whether it is class A or class B or class C by seeing this number. Okay. So same way, the system also need to understand, right? Like how it will understand. So for that only we have a subnet mask. Are you able to see it here? The subnet mask here. I'm highlighting. So it will tell the computer like which network it is, which class it is. Okay. So right now, my IP is in which class?
Class C.
Class
C.
C.
C, right?
Yeah.
Yes.
Yes, it is in C.
So why the subnet mark is marked as a 255.255.0? So how many network bits we have in the class C?
3.
3. So that means, so it represents your networks. The
Class C.
subnet mask represents your networks, right? So
Yes.
if it is the 255, 255, 255.0 for class C, what is the value for class A?
255.000.
Yeah, that's correct. What is for class C, B?
255.255.00.
So 255.0.0.0 for class A and 255.255.0.0 for
Class B.
B.
class B and 255.255.255.0 for class C. Okay, so this is our subnet mask. So how they are calculating it? Simply, man, I told you network always represents with 1 and host always represents with 0. Okay, so we have total 32 bits here and each octet you have 8, 8, 8, 8. So just mark, so host is always 0, just keep it 0, 0, 0, and network bits 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So what is the value of 248? 256, right?
Yeah.
So we are counting from 0 to 255. So that means it is 255 dot. So what is the value of other one? 255, right?
255.
And what is the value of last two octets? 0 dot 0. So that's how they are calculating. So if I give any IP, you will calculate or not.
Yes.
Yeah.
Yes, sir.
So you got it right? Subnet mask.
Yes. Yes.
Yep.
Yeah. Okay. That's fine. So now, so you got subnet mask and you have some idea about the IP addresses and you have everything now. So, okay. So these IPs like this class A, class B, or class C, whatever, these are divided into public and private IP addresses. Okay. Public IPs and private IPs. Public IPs. Let me give you the private IPs and rest all are public IPs. Okay. So for class A, we have 10.0.0.02, 10.255.255.255. So these are our private IP in class A. In class B, 172.16.0.02, sorry, it's 16. 16.0.02, 172 dot 172.16.31.255. So this is class B, and class C is 192.168.1.02, 192.168.255. So these are the class B ranges. Okay, so these three are the class A, B, C ranges of private IPs. Okay, what is the difference between private IP and public IP? So if you assign this IP, you won't get any internet. Okay, and so I'll tell you the difference. So what is my public IP, private IP? 192.168.29.41, right? But what is my public IP? So just leave about IPv4, IPv6. So you're saying, right? My public IP is different. And it is in which class? It
Class
is in
A
which
only.
class, guys?
Class A only.
Yeah, class A. Okay. So I'll tell you why they divided public and private. Okay. Everyone needs internet connection, frankly. So without internet, nothing will work. So you have 17 million in class A, 65,000 in class B, and just 255 in class C. So when the computers was introduced, maybe everyone is buying an internet connection. Okay, we are buying an internet connection, right? But that time, what it is like, one guy will have one dedicated IP, one guy will have one dedicated IP, one guy will have one dedicated IP. So don't you think like we have 17 million users overall in the world to use the internet? So we have, right? They will buy it and they can use it. So they started using that, and the IP address is going to be we are going to lose the count. And even class B also and class C also, because you have only 255 only. Like you can give it to 255 members only in a network. I'm talking in a network. So whatever the IPs, we are talking in a network, okay, not in old class C. I am talking in a single network. Okay. So single network means, so this 10.0.0 to 10.255, this becomes a single network. Okay. And this 192.168.17.31. So this all becomes a network. 1.0 to 192 to 168, 1.0 to 192 to 168, 1.255 is a single network. Okay, I can assign 250 hosts in a single network. 1.0 is a till 1.0 is a single network. So now if I want to assign more, one is filled up, right? I can move to 192, 168, 2.1, right? 2.2, right? And 2.255. So again I have 255. So that doesn't mean like I can give only 255 hosts in class C network, not entire class C. I'm talking in a single network in class C. Because in class C, how many networks we have? We have from 192 to 255, right? Not only 192. We have many networks. Okay, that's why in a single network we can give 255. Same way in a class B, in a single network you can assign up to 65,535. In class A, 17 million. Okay, so when they decided like it is going to use by everyone and we are going to like lose the IPs if one person uses one IP, so they decided like we will assign some private space. So this class A 10 network and class B 172 network and class C 192 network, these won't have the internet connection. Like you will use it in your local LAN. Like I will use my IP in my local systems, like for my company users. But while going internet, I will go with a different IP. So you are seeing, right? I'll going with this IP. But internally, I am using 192.168.29.41. So these are the private IP spaces and public IP spaces. So rest all like a 1.1.1 and 49.1, 50.1, everything becomes a public IPs. Okay, guys, you got it? So private IP space, just remember these are the three in each class. Class A, class B, class C. So wherever you see, you will see all these only. Okay. So what is the subnet mask of class A? How many networks we have in class A?
One.
1.
So what is the subnet mask of class A?
0 to 1.
255.0.0. Class B 255.255.0.0. Class C 255.255.255.0. So it represents /8, it represents /16,
Slash
it
16
represents
slash
/24.
24.
Class A, B, C. So wherever you see, you will see only these three private networks. Okay. So there is nothing to worry. These are the common, like it's defined, predefined. So there is nothing to change. And mostly you will see these three only. And for outbounding, like to go to internet, we will do the netting and all those. So we'll get to know about all those things later. No need to worry about that. Yeah. Uh, I think we are good. Hope everyone got it, everything.
Yep.
Yes, sure. Sir.
Okay. So same way, whatever you explained today, you need to explain everything on IP addresses tomorrow. Okay.
Okay.
Yeah, definitely. Because IP addresses are mandatory, and without knowing the IP concept, you are not a network engineer. You are not eligible actually.
Okay.
So just concentrate on that. Just go through that, and we will discuss if any doubts. Okay, don't worry about it. And so these are one more thing is there in the IP addresses, but yeah, that's fine for today. Like no need to overstress. We'll discuss everything tomorrow.
Okay.
Okay, we will like there are few things. Yeah, we'll discuss them tomorrow.
Okay.
చలో మరి బాయ్ అందరు వర్కింగా లేదంటే కాలేజా
Working.
ఓకే సో వర్కింగ్ యాజ్ అ నెట్వర్క్ ఇంజనీర్ ఆర్ డిఫరెంట్ ఫీల్డ్
Different.
ఓకే
Different fields.
ఫైన్ నో ఇష్యూస్ యా ఓకే హ్యావ్ ఎ గ్రేట్ డే గైస్ బాయ్ ఐ విల్ మీట్ టుమారో సో టుమారో సాటర్డే కదా వద్దులేండి సేమ్ టైం ఓకే అవసరమైతే ఒక గంట ఎక్స్ట్రా తీసుకుందాం కానీ స్టార్ట్ ఎట్ ద సేమ్ టైం
Okay.